and we're going to be solving one-step equations. Now, you may be able to solve these without showing work, but it's going to be important that you do show work because we're going to be moving on later in this chapter to two-step equations or even more, multi-step equations. You cannot do these in your head. To solve one-step equations, you're going to be using inverse operations. Inverse operations is like opposite operations. For example, if they're adding, you're going to do the inverse operation, subtract, to bring that quantity to the other side. Or if you're multiplying, you're going to divide, and vice versa. Okay, so let's start with x plus 3 equals 9. Yes, you could probably do this in your head. That's awesome. But we need to learn how to show work when solving one-step equations. We're going to use the inverse operation. The inverse operation will be subtracting. Opposite of adding is subtracting. And I'm going to bring this quantity to the other side. So I get an answer of 6. You are going to be checking your homework. To check your answer, you're going to plug in the x into the original equation. My goal when checking is to see if both sides are equal. So I'm going to solve the left side. 6 plus 3 is 9. If both sides are equal, that means that this is the correct answer. Let's try another word. Let's try x minus 2 equals 11. To solve this, you're going to use the inverse operation. Opposite of subtracting is adding. And I'm going to bring it to the other side of the equal sign. Okay. I'm going to check my answer by plugging it back into the original. Instead of x, I'm going to put 13. 13 minus 2. Solve this side. If both sides are equal, that means that this answer is correct. Okay, I have 2 for you to try. These look a little different. They're harder than the ones that I did. Negative 10 equals b plus 3. Solve and check that one. And the other one is negative 5 equals negative 2 plus x. Right, so those are your adding and subtracting problems. Let's try some multiplying and dividing. Let's do negative 4x equals a negative 28. Again, you're going to be able to do this in your head. You should be able to figure out 4 times what number equals a negative 28. But we need to learn how to show our work because once we get to the multi-step equations, we cannot do it in our head. So you're going to think, what's the opposite inverse of multiplying? Well, the opposite of multiplying is dividing. And I'm going to show division by using the fraction bar. That's gone. It's gone off of that side. Whatever I do to one side, I do to the other. Negative 28 divided by negative 4 is a positive 7. Still check your answers. Plugging in 7 in place of the x. Solving that left side, if it's equal to the right side, that means you solved correctly. If this side is not equal to the other side, that means that this answer was incorrect and I need to resolve. Let's try t divided by negative 2 equals 9. Fraction bar means divide, so the inverse operation would be to multiply. I'm going to show multiplication by putting the dot off to the side. It's gone off of here. 9 times negative 2 is a negative 18. Let's check to see if that answer is correct. Instead of t, I'm going to put in a negative 18. Or negative 2. Solve this side, it means divide. Both sides are correct, so this is the correct answer. I have 2 for you to try. Try negative 65 equals 5y to do that, we would do the inverse operation. They're multiplying, so we would divide. I'm going to rewrite this so it's easier to read. We learned in the past that you can't divide fractions. Instead, you're going to multiply by the reciprocal. So keep, switch, flip. Turn this into a fraction. I could multiply straight across and get negative 45 over 3 and reduce it. Or I can cross reduce, so I'm going to take 3 out of both of these. Negative 3 times 5 is negative 15. 1 times 1 would be over 1. Okay. That's a long way to do this. This says 15, not 5. There is a shorter way to do this. And it's going to be your choice on which method you want to use. You see in this step right here, we ended up multiplying by the reciprocal. What happens if we multiply by the reciprocal right away instead of dividing? Because division in fractions is the same as multiplying by the reciprocal. Fraction, so it's easier to do math. Again, you can multiply straight across or you can cross reduce. Negative 3 times 5 is negative 15. 1 times 1, you can put it over 1. Either way, you're going to get the same answer. I suggest when you get to problems that have fractions in it and you're supposed to divide, multiplying by the reciprocal instead. Let's just check this to make sure that we have the right answer. Check with fractions. So 3/5 times x, which is a negative 15, equals a negative 9. Okay, to multiply a fraction and a whole number, you're going to turn the whole number into a fraction. You're going to cross reduce. 3 times negative 3 is negative 9. 1 times 1 would be over 1. And both sides are equal, so I know that this answer, either way you solve it, is correct. Your turn to try.